Hello everyone, my name is Rajat Gal, a former Microsoft engineer and an educator and founder at Bosscoder Academy. Welcome to this class. In this class, we are going to learn about the scalability aspect of live streaming platforms like Disney plus Hotstar. I hope you love the class.
Let me start with the agenda. So tell me, when you see video streaming platforms, what type of platforms do you see? For example, if I tell you one type of platforms, have you seen platforms like Netflix? These are something that do recorded video streaming, right? Like Netflix, like YouTube, if you are watching YouTube videos, right? Or there are on Disney plus Hotstar as well. There are recorded movies, series. There is again Amazon Prime, multiple examples. This is one type of streaming platforms. Another type of streaming platforms are live streaming platforms. These are platforms which stream live videos at scale, right? For example, Big Boss, you might have heard this news of that Elvish Yadav break all the records of Instagram live. They were, I'm not sure how many people, but a lot of people were watching, were listening him live, right? So that is again live streaming that is happening. That is Instagram live, or YouTube also have again live streaming. You have World Cup matches, for example. Right now, I think a cricket match will going to start on Hotstar, Disney plus Hotstar. We have World Cup. We have again, I think Asia Cup is happening as far as I know. Not 100% sure. FIFA has happened on Geo Cinema. All of this. These are what live streaming platforms, right? Makes sense. Another type of platforms which you would have seen is these are where in this platform mostly the audience is not speaking anything. His audience is passive. When you are watching cricket, you are just watching cricket, but you are not really interacting with the video stream. You are not part of the video stream. You are not going to change anything in the video stream that is going to shown to the other people. But when you see platforms like Zoom, right, whenever a meeting is happening, right, or you see platforms like Microsoft Teams, right, all of these, when big meetings, let's say with 10 people or 100 people meetings, 50 people meeting or 100 people meetings are happening, then all of their cameras are open, right? And all of those are part of the video stream and creating video stream, right? So these are another type of streaming platforms where multiple people are part of the streaming process. Does this make sense? Everyone clear? There are usually these three types of video streaming platforms. Today we are going to cover these two. We have covered all of them in earlier classes as well. We have covered this designing of Microsoft Teams, designing of Zoom. We have also covered this earlier as well in Geo Cinema. We have covered this as well. Today we are going to cover these two, and we'll try to see first. The first thing we will do is we'll try to understand how to build a recorded platform, recorded streaming platform like Netflix or YouTube. And then we'll take this learning from this platform and apply to live streaming platforms like Disney plus Hotstar. Okay. Is everyone clear till now? A quick yes, if everyone is clear. We will cover, Sunil, this, whether videos are in chunk, whether videos are entirely loaded or they are divided into chunks and then loaded. Okay, great. Looks great. Let me just share one more thing, and then in the agenda, which will again give you more clarity, and then we will start. Let's consider a platform like YouTube, right? Again, as I am saying that we will cover this first. So let me start with this part of designing a recorded video streaming platform like YouTube or Netflix, like something around those lines. Right. So let's start. So you tell me, whenever you are designing YouTube, the first part of YouTube's are people here who are known as content creators. What is the work of a content creator? They are going to create videos and then they are going to pass this through a YouTube system. What is the name of the YouTube system? We will cover YouTube or any system. And then this is going to upload it on the YouTube server, right? Does this make sense? What happens in this system? Can you tell me? So when you think of this system that is first taking the video, so what is the goal? Goal of this system is it gets input as a video and the output is to upload it on server, or I would say YouTube server. Now, what is the process for it? Usually there are two things that are happening within this system. One thing is, the first thing that is happening within this system is uploading. And another important thing that is happening is processing. What is uploading? Uploading is you are uploading the video, right? Just very, very simple. The first thing you will do is you will upload that video, persist that video on your database, on the YouTube's database, right? That is the very, very first aspect. What is the second aspect? Second aspect is also very important. So do you tell me, can you upload any video on any type of video on YouTube? Or there are some policies that you have to adhere while you are uploading video on YouTube? There are restrictions, right? There are restrictions like there are YouTube policies. For example, there might be policies that you cannot post adult content, you cannot post violence related content. There are Indian, like country specific laws. For example, if you are in India, you might not show, you cannot show POK as part of Pakistan. You have to show it as part of India, or within like disputes with China, or some type of content that you cannot show in India, right? So that is also their country specific laws you have to adhere as well. You also have to adhere to copyright issues. You cannot just take anyone's content and just use it, right? That is also a thing. Then before even uploading the video, these are some checks that YouTube is going to do. Other than these checks, there are some other aspects YouTube will also check, right? For example, it will make sure that the video is chunkified. Again, what it is, I will cover it in some time, but it is basically breaking down video into smaller parts. Maybe it will create the video into different dimensions for fast viewing. So for example, it will convert the video into 240p, 480p, 720p, 1080p, and then distribute based on the bandwidth of the user that is watching the video. You might want to create subtitles for the video, right? Does this also make sense? So then you have to do some of these steps as well. That makes distribution easy and fast. Does this make sense? All of this, does this make sense? All of this is part of processing. So you have to do all of it before you finally make the video available for users to view. After this system is done, now the final output, I think the better way to write it in works is that output of this system, input of this system is taking a video, then it does all of the uploading and processing, and then the output it gives is that it makes the video available for distribution. Does this make sense? Right? Everyone clear till this point of time? Everyone with me till now? A quick yes. Just keep writing yes, no questions. This keeps interacting. Even if you have some insights, I see some people already have knowledge who have worked in this field. Maybe they can add more value to the class as well, and we can learn from their experience as well. Right? So this is the first thing. The second thing is, now once the video is available here, you want to distribute it. So the second part of the system, another YT system that will be there, is major role of this system is to distribute this to end users. There are a lot of users. So these are content consumers, people like us who don't create content, but consume videos, consume content a lot. And the system has to make sure that it distribute at scale, right? There are so many users, and also distribute at low latency. Low latency means that buffering should not be there. Video should be very, very fast. Does the overall system make sense? This first part of the YouTube system, which is uploading and processing the video, is known as a video ingestion system or a video ingestion pipeline. Why is it called a ingestion pipeline? We will talk about it. Why is it a pipeline or something? But it's known as an ingestion pipeline, right? And this is the distribution system. If we understood after the end of the class, how does the ingestion system works, ingestion pipeline works, and how does the distribution pipeline works, then you understand how to create a video streaming platform record it, right? And then after that, we will take that as our like fundamentals and build live streaming on top of it. Does this make sense? What is our agenda? Our agenda is very simple. Let's learn how does the ingestion pipeline works. That will be our first thing that we are going to cover. We will understand how does the whole ingestion pipeline work. Then we will understand how does the distribution work. After we understand both of it, we will combine our knowledge of both of them to learn how does a recorded streaming platform works. Once we know all of this, we will make it as our fundamental building block. And then top of it, we will build our live streaming. This is how this whole class is going to revolve around. We will start with this, cover it in the around 40 minutes. Then we will take a quick break. Then we will cover distribution. Then we will cover combination. Distribution is easy. It will take around 30 minutes. This will take around 5-10 minutes. And then finally, we'll spend next 20 minutes on this. This is how the whole class will look like. The whole overall 2 hours that you are going to spend here with us. Okay, any question in the agenda, and I can help you explain that. Let me also put my laptop on charge, otherwise it will get like off in between, and then we can start. Okay. Okay, great. We are good to go. Let's start then. Great. So let's start. Let's start with the ingestion pipeline. Overall goal is clear, very simple. In ingestion pipeline, 2 things are happening. Uploading is happening, then processing is happening. What is processing? A bunch of steps that are needed to be done before making the video live. So let's start. Let's start with a very design one. Like very, maybe like brute force design, I would say. Right? Let's start with a very first design, very brute force kind of design. Okay. So how will the design look like? Again, drawing very rough design. I will design the complete design after all, but like now I'm designing very rough. So let's start with the client, right? What is a client? A client is something from where the user is interacting the service. So it's like a mobile device. If you are uploading the video from the mobile device, or if you are uploading it from your laptop, right? Or you are using a command line interface, whatever it is, right? Or if you are hitting an API from browser stack. No, you will not get the recording. You will get the notes of the class. Whatever I'm writing here, that you will get, but not recording. This is meant to be attending live, right? Recordings are there a lot, but if you stay committed to 2 hours, you will learn a lot. Okay, so let's start with brute force design. Very simple. There is client, right? Now, let's say this is the Netflix, let's say YouTube server, right? This gets the request of uploading a video. Let's say I am doing the upload of video, right? So the first thing is the upload of video will take place. So then the video will get uploaded to a database, right? Here, persist the video. Here the video will get persist, right? And it will get the URL. Video will get persist in the database and it will get the video URL. It's kind of a blob storage. Like at your blob or AWS S3 kind of that storage. Very simple. Just uploading video and you are getting the video URL from here. Make sense? You will get that. Now the second step is, this is sending the video URL for processing. And it is giving the video URL to another server that is doing the video processing. It is doing the video processing very simply. It is doing all the steps sequentially. 1, 2, like for example, 1 can be copyright issue. Second can be Indian law. Third can be YT laws. Fourth can be chunkification. Fifth can be again subtitles, quality, multiple areas, and it is doing sequentially these steps one by one. Okay. Yes. Great. Thank you, Rohit. Please keep answering each other's question, right? I cannot answer all the question. So if you guys answer each other question, that will be very, 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 very good, right? So this is how the first system looks like. Then the server sends the response. Once the video is uploaded and everything is done, video is processed, we reply back to the first server that, okay, video processing is done, and then it replies back to the client that it is done. Is the approach one making sense? Very, very simple brute force kind of design. Making sense? How does the overall system for ingestion is looking like? Great, great, great. Tell me, what are the disadvantages, or like, do you see any disadvantages within this design? You do not want to do all the operations on the video itself. Like, you don't want to pass videos here and there. You just want a URL, and that with the URL, you can directly connect with the server. Yes. So Rohit has first very good approach. User first thing that Rohit has mentioned is good. Second thing that Rati has also mentioned is good. Amin also same thing that Rohit also want to say. Divya has also the same point to say. Yes, 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 yes. Multiple right things. So let's start one by one. One thing is that it is taking a lot of time, right? Because you are doing all the processing steps sequentially. When do you think? When do you do sequential steps? Like, inherently, you do sequentials when the second, then the response for the second depends on the first, right? If my second thing depends on the output of the first thing, then I have to do it sequentially. But do you think here you need to do sequentially? Can you do copyright issues and Indian laws parallelly? Start both of them at the same time? Yes, right? So you can do a lot of parallelization here, right? So that is the first thing, that it is taking a lot of time because processing steps are getting sequential. Approach towards solving it is, the very good approach is parallelize some of the operation. Okay. The second that Rohit has also mentioned and some other people have also mentioned, why is the client waiting for the processing? You tell me, do client have to wait for processing? If you upload any video on YouTube, what will happen? You will upload the video on YouTube. That will be the first step that will happen. Then the YouTube will say you, now go have fun. Close the browser. Like, you close the browser. No problem. Just close the browser, have fun. I will do the processing in background. And once it is finished, I will let you know. So user don't have to wait for processing. Okay. Does this make sense? Or I would say not user, because user will definitely save, but the better word would be client. The client don't have to wait for the processing to be complete, and it does not have to hold on to that request until the processing is completed, right? These two things, I think these are something that we can improve upon, right? Agree with me on these two aspects? Then let's improve it in the second design. Yes, we'll come to Q as well, Sunil. One by one, we will come to it. But is these two things making sense? A quick yes if this is making sense, these two aspects. Okay, great. Great. If these two aspects are making sense, let's create another design. Let's create design 2. A improved version of it from the design 1. One thing that people mentioned here is it is taking a lot of time, and let's solve the first aspect which we talked about, which is let's do the things in parallel, right? So the thing is do processing steps in parallel. So one approach towards solving it is, like, one approach towards solving this problem is, the approach one is that you do all the steps in parallel. So for example, you can start doing everything in parallel, like copyright, Indian law, then YT policies, then another thing which is chunkification, quality of video, subtitles, right? 240p, 480, 480. Is this the right approach? You tell me. Is this the right approach to do things? Like do everything, all the processing steps in parallel. Yeah, better than last, definitely. Yes, better than last. But don't you think this approach is fast? Definitely this is fast, but do you see that a lot of resources are getting wasted? Does this make sense? Why do I say so? Because if the sort of reply to everyone so that others can also see your aspect of thinking, right? So how are resource wasted? Yes, let me tell you. Let's say the copyright fails. Copyright fails. Now tell me, do you still want the quality things to be done? Converting the video into 240p, 480p, 720p, chunkification the video, subtitles. Do you want all of these things to be done when even your copyright has failed? No, right? You don't want to do that. But in this approach, are you doing it? Yes, you are doing it in this approach. So that's a waste of resource, right? Makes sense? So definitely this way, approach one, it will be faster, but it is going to waste a lot of resource, right? Tell me one more thing. Tell me one more thing. That do you need to make processing really, really fast? Is it very important for the business requirement to be very, very fast? It should be reasonably fast, but not very, very fast. Because again, processing is happening in background. Okay, so it is not really short, not really needed to be very, very fast. Okay, I will just summarize it. If someone is getting like a bit overwhelmed, I will summarize it. But let me come to approach 2 and then I will summarize. The better approach towards solving it is you are given the video. Let's do this. Let's make stages. Let's create stage 1. In stage 1, we will do parallelization. That is, we will do Indian law. Right? We will do copyright check. And we will do another thing, which is, let's say, YT policies. Once these are done, right? Once this is done, then we will go to stage 2 task. Make sense? Stage 2 design. Then in stage 2 task, you can do other things like chunkification. Again, like some other aspect, quality check. Then maybe after this, you can do subtitles in stage 3 or some other task. And once all of them are completed, then you can say video is processed. Is this making sense? Yeah, name, I will come to it. Name does not just matter too much, but is this making sense? If you see more clearly, this is a directed acyclic graph. Like if you see, it's a DAG. If you have read about graphs, it's a directed acyclic graph. It does not have any cycle and it's directed in nature. So you can use DAG algorithms in order to make this whole scenario very, very fast. Like whole of this operation, you can use algorithms of DAG, give weights of how much time does it take on an average for each one of them. Then my goal is to reach up to this time. How can I define this directed acyclic graph so that overall my efficiency is very, very good? Yeah, we will. Sunil will come to that as well. Just give me some time and we will. Yes, Avinit, you are right. So if anyone fails at stage 1, then you don't go to stage 2. So you end up saving resources. Right? Is this making sense? Should I repeat once? Do you want me to repeat once in 2-3 minutes? Okay, let me just repeat it very quickly. Right? The major problem we were facing with the first design, if you would have seen the first design, is one of the problem is that it is taking a lot of time to do all the steps sequentially. So what we thought is let's do parallelization. Let's do parallelize operations, right? So in parallelize operation, the first approach we took is that let's do this. Let's do all of the things in parallel. Very, very fast, very quickest, right? But it is quickest, definitely. But it has one disadvantage, which is that a lot of resources are getting wasted. Why the resources are getting wasted? Because even if copyright fails, I will still end up doing chunkification, quality, subtitles, and a lot of things, which is just a waste of resource. Since the copyright itself fails, why do you want to do other things, right? Make sense? So that is one problem. So what we did is we created this directed acyclic graph and created stages. So in stage 1, you will do some tasks. When they succeed, then only you move to stage 2. When stage 2 tasks complete, then you move to stage 3. When stage 3 tasks complete, then you finally say video is processed. So in this way, you are keeping a boundary at every stage. Yes. How does this actually look like? This is again, there might be multiple other steps within this whole step. I have not written all the steps that YouTube would have done as part of processing. I don't even know what all steps are. But if they have these multiple steps, they will create this kind of pipeline to make sure that they are not using a lot of resources. At the same time, they are able to deliver processing very, very fast. Is there any place? We are starting, Tony, now our YouTube channel. So you will see more content on that. It's not very, very active till now. We are starting now. We have not done a lot of YouTube in the last 2 years. But yeah, if you want, we will be posting these kind of sessions on our YouTube channel in future. So yeah, you can maybe recordings of these or something else. So you can subscribe to the YouTube channel, and in the next couple of weeks, you will see. Okay. Okay, let's move forward. Is this making sense? A quick yes. Right? Okay, great. Please, everyone, please help each other out. For example, Siddharth is not able to understand some part of the design. So someone can summarize it for him, right? Like I cannot be able to answer all the questions given the time constraints I have. But if you have, then you can please help them out, right? Okay, that was the first aspect of parallelization, right? Of all the things. Now let's move to the second aspect, which was there. The second aspect, yeah. So this is what the company name is. Yeah, you can search more about us on, like, go to Google, search Bosscoder Academy, or I will have an open-ended Q&A at the end. I will answer all the questions, right? Let's stay to the topic for now so that we cover maximum in great details. Okay, the second aspect which we have is which was very, very important after the first aspect was that within, if you remember here, within our design that Rohit was mentioning, right, that we need the second that we can wait in the background, right? We don't need to wait, make the client wait until the processing is done. We can just do it in the background, right? With all of those, with combining both, let's create our design tool. Now, what we have learned and what has been, what we have learned till now, let's design it. So again, this is the client. Client is again your mobile app or your laptop, whatever it is, or your CLI, whatever it is. Now this again goes to the YT server, which gets the video and then again persists it over the database, a blob storage. So it persists the video, and after persisting, it gets the URL of the, or I would say it will get the video URL, right? Yeah, YT means YouTube. Okay. Once after that, now we have, once this is persisted, we have sent the response back to the client. Client got response that, okay, uploading done. I will let you know once processing is done. Okay, make sense, right? Does this make sense? Okay, great. Now it goes to, it takes the video to another server, which is made for processing of video. One more thing it will do, like to know the stage of the processing, it will maintain that stage. Let's say it maintain the stage here, right? So here now the request goes to it, and now this server, maybe let me explain it like this. Now fifth stage will be processing of video. Now do you understand parallelization is happening? Remember that directed graph, cyclic graph, that parallelization is happening. So what will happen once it gets the video, this server, there will be algorithm written here, and it will first set the request to the stage one request. So let's say the stage one servers are here. Stage one. Now again, there can be parallelization here. So all of these are parallelized. So there are one set of servers which are handling the scale of what? One task. For example, let's say copyright issue. There are other set of servers that is handling another issue, which is, let's say, Indian law. There are another set of servers which are handling another set of things, let's say YT laws. And they together contribute the stage one request. I will share you the PDF of this, right? So this server first sends the request to all of them at one point of time, parallelly, right? And then it gets the response from them. Once it gets the success response from all of them, then what does it do? It sends the request to the stage two servers. Right? Stage two servers can now have different things. It can have chunkification. It can have quality, multiple aspects. And then the request will be sent to all of them parallelly after stage one is completed, right? So this is sent to stage one. Sixth step will be sent to stage one. Once all of this is one, chunkification, I will tell you, give me some time. Just think of it as one step in processing. What it is, you will get to know after half an hour, right? So after stage one is done, then the request will be sent parallelly to stage two, right? Seventh step will be sent to stage two. Okay. Similarly, once this is done, the request will be sent to stage three. And so on. And once all of the stages are concerned, this will get to know that video has been processed. This lets the YT server know that video has been processed, and that sends out a notification or update somewhere in the database that, okay, your now processing is completed and this is live for distribution. Yes, Kashi is right. That is what is known as chunkification. Is this approach making this? Is the design 2 making sense with parallelization and with that aspect of not letting the client wait for the processing stage? Everyone clear with this? Okay, great. Do you still see any disadvantage in this? It is very scalable. Why? If you see that this approach is scalable. Why do I say so that this approach is scalable? Is see, even do you see that there can be different type of the one very good aspect of this design is, if you actually go about seeing the beauty of this design, one very good aspect is that you can scale each operation separately. Is this making sense? For example, it might be the case that copyright check takes, let's say, 5 seconds for one video, whereas chunkification takes 1 minute for a video. Is this making sense? Now, since chunkification is going to take more time, you will need more servers here, more resources here. And now you can scale this independently. That is the first beauty of this design. Is this making sense? A quick yes if this is making sense. Yes. Right? This is one very good beauty. The second very good beauty is, for each step, for each operation, you might require different hardwares. And here you can do that as well, right? It might happen that for chunkification, you need different kind of hardware than what you need for checking of Indian laws. And you can do that. For example, for machine learning algorithms, we use GPUs because they are very, very good at doing maths calculation, matrix calculation, right? and that is something that you can also do. Right? What I am saying here is Tejesh, is the beauty of this design, if you see, is that you can scale each operation separately. For example, let's say copyright takes 5 seconds and chunkification takes 1 minute to complete for one video. Right? Now, it is obvious that you will need less servers on copyright and you will need more servers for chunkification if you have the same type of server. So here you can scale things separately. You can have less servers on the copyright operation and you have more servers on the chunkification operation, which is a very, very good aspect of this design. Second important aspect of it is that you can have different hardwares for different operations, which is also very, very good. But despite of all of this, there is one severe disadvantage that this approach has. What is that disadvantage? Yes, yes, Manish. Like one more optimization that you can do is that, as Manish has mentioned, right now we are uploading video 2 times, right? Manish is right. We are uploading video 2 times right now. One is we are uploading from client to YouTube server. This is one upload. And then from YouTube upload to blob storage. This is second upload. You can make it to one upload. Why? How? You can go to the client. You can go to the server. The server will go to the blob storage and give you a key. The server will send the client a key to access the blob storage. And then using the blob storage, client can directly upload. Using the key, the client can directly upload to the blob storage. But you cannot give direct access to the database, remember. Otherwise, there is a security issue, right? You have to give it a key. You have to make sure that there is a handshake, like there is in payment apps. If you have designed I have designed Paytm in the past, like used Paytm for one of the services that we were building. If you implement Paytm payment gateway on your server, on your site, then you will see that handshakes are very important. So that is the same concept that you will use here. Yes. Yes, I think that is also good. You can have a stream pipe from client to server to DB. Yes. Okay, I think that's a small optimization. Yes, definitely can do. What is a big problem you see? Yes, yes, Manish is right. You are right. Security has to be taken care of. Yes. Yes. Tell me, what is a major problem? Definitely, these are aspects that we will definitely take care when we are designing an actual system for sure. What is a major problem, but however you see that is very, very important to solve? Load balancing, yeah, that will happen. I have not written it. I will just write it. Yes. So one aspect that we are still lacking is this. Do you see that for every video, this server is holding up to the request until the processing is done? Do you see this, that this server is holding on to one request in one thread until its processing is done? So until the whole processing of a video is done, a thread is open here for one single video, right? So for every one video, one thread is open and tracking the progress of the video processing. Is this making sense? For example, here you will write async request. You will write async, send it to all of them, and then wait for you will do async await. I will wait for the response of this. That means a background thread is being opened that is waiting for all of these to complete. Once these are completed, then it will context switch to the main thread and then sends it to the second set of operations and then again wait in the background thread. So for every video, you have one thread that is open. If this server is handling thousands of video, then you have thousands of threads open in the server at one point of time. What happens when a lot of threads are open? Your systems become slow, right? You should know about, if you have read CS operating system, then you will know concepts of thread cores. Both of them correlate very easily. Like one core can only run one thread at a time. Can only run one thread at a time. Right? So if you have a 2-core machine, like core i2, then you can at one point of time, you can only run 2 threads. And then what your CPU is doing is, it is context switching between multiple threads. If this context switch is too much, your system will slow down, right? So you should make sure that whenever you are designing and writing code, you should not open too much thread. Otherwise, it will lead to slow operations, crash, and kind of bugs that are very, very hard to identify. I have solved it once in PowerPoint, a thread issue. It was thread synchronization issue. It was, it's very hard to catch, really telling you. But if you are a good developer, you will keep, whenever you are writing code, that will go into your state of mind, or whenever you are doing reviews of code, it is going into your state of mind. So what can you do here? Like, is the problem making sense? Like a quick yes if the disadvantage is making sense. Like, before I go into too much detail, because then some people will not understand it. But on a very logical sense, is the problem making sense? The problem is that this system is holding on to one thread for one video until it is completed. This is the problem, because there are multiple videos that are coming to the server, and it is holding the thread for every one video, which is a bad thing, right? What is the solution to this? Very good solution to these types of problem is something that Kashi has mentioned, is Kafka or messaging queues, right? These are known as distributed messaging queue. Very good solution of solving them. There are distributing messaging queues like Kafka, like RabbitMQ, right? All of these are very, very good platforms in order to handle it. Do you guys know what is a distributing messaging queue? What is a Kafka? What is a RabbitMQ? Like, what are distributing messaging queue? Okay. Great. Okay. I will not be able to explain it completely, but maybe I will give you an analogy, and then we'll give you a homework of reading it. I have done a masterclass on just distributed messaging queue in the past, and it usually takes 1.5 to 2 hours to help you explain completely what is a distributed messaging queue, and that takes a lot of time. So maybe, like, what I will do is I will give you this homework that you go read about distributed messaging queue after this class. But right now, I will give you enough analogy of, like, comparing it to real examples, so that you are able to understand the rest of this lecture, right? Okay. So let me give you this analogy. Let me take the example of Rahul, since Rahul is the last person who has typed. Let's say this is Rahul. Let's say Rahul is married. Let's say Rahul is married to, this is Rahul's wife. And let's say this is Rahul's kid, right? Let's say these are the three areas. Now let's say Rahul's wife, Rahul has this responsibility of taking the kid from home to school in the morning. Every day Rahul used to take his kid from home to school. Now let's say he has some offsite, he has to go to Hyderabad, or he has to go to some other place for some work, or he is going on a trip and he is unavailable for this day. And Rahul gives this responsibility to his wife, that now you go take the kid to the school, right? There are two ways Rahul can react, right? Rahul is somewhere else. Thus, way one Rahul can react is, Rahul have given this responsibility to his wife to take the kid to the school. Now, one thing that Rahul can do is, while his wife and kid is going to the school, he keeps pinging his wife and kid, right? That tell me, have you passed the lane 1? Have you crossed that, right? And then he will get a response. Then he will again ask after some time that, have you passed the lane 2, right? Then again he will receive the response, right? Then he will again ask, have you dropped the kid to the school, right? Then he will again get the response. Then while his wife is coming back, he will again keep on asking, and he will again keep on getting response, right? This is the approach 1. This is the way 1 that Rahul can react, being like very worried and asking multiple times from his wife where they are, does she reach home or not? And until she reaches home, he is not, like, he has kept a thread open in his mind, which keeps checking for where they are right now. This is the way 1, right? Makes sense? The way 2 is, the way towards how Rahul can react is that this is the home of Rahul, and this is again the school. Now Rahul say that, I know my wife is very, very responsible. She has all the potential to take the kid to the school and come back. I know that if any difficulty even arise, like a traffic jam will come or anything can come in the way, she can handle it by herself, right? So what Rahul does is, Rahul gives the responsibility to his wife, which takes the kid to the school. But now Rahul is not keeping any thread in himself. He's saying, now I have given up my responsibility. I am done. Right. And now the wife takes the kid to the school and then comes back to the home. Is the way 2 making sense? What you tell me, which is the better way, way 1 or way 2? For Rahul, at least. For Rahul, what is a better approach? For Rahul, of course, way 2 is better. Since now he can do other works. Since now he is free from other aspects, he is free from his thinking around it. He can focus more on other tasks and can focus more of his bandwidth on other tasks, right? Again, like if you compare it to the video approach of YouTube, right? Rahul have multiple wives, right? Because Rahul is handling multiple videos. So Rahul does not have one wife. If you compare it to the video approach, Rahul has multiple wives and multiple kids. And that is where the problem begins. It's not just one wife that he has to keep pinging. It's hundreds and thousands of videos that he has to keep pinging and asking, which makes him very, very busy, right? So that is why it is better for Rahul to just take up the first approach and live like a tension-free life, right? Way 2 is better. However, while this approach is better for Rahul, Rahul being a good parent wants to make sure that his wife and his kid is well off. So for that, his wife has to take up this role that his wife will be able to handle all the problems that come in the way. Right? For example, his kid is saying no to go to home, or his kid's shoe is broken. So now that processing step is broken, or there are traffic jam in the way, some servers are not working. All of those things are happening, and she is able to handle all of that task. Now here the Rahul's wife is a Kafka or a RabbitMQ or a distributed queue, which has all the potential to handle all the error and take multiple kicks, which are multiple videos, to their end destination and come back. Right? Rahul's wife is solving it, right? If Rahul's wife is caliber enough, then there can be multiple kicks. Each kick distribute means that there are videos. And she can handle all of that very, very easily. Is this making sense? The objective of Kafka? The objective of Kafka is to take up that item from the server, which we need here. Since this server is holding on to the request. So what is happening? This server is now giving its responsibility to the messaging queue, the Kafka. Given the Kafka has the caliber and the potential to handle all the errors by themselves. A quick yes if the analogy is making sense. If the Kafka analogy is making sense, then we will draw it quickly. Okay. Okay, makes sense. Just a disclaimer before I move forward. In this, now for next 5 minutes, it might happen that you will not understand some aspect. If you have not read Kafka before, or you don't know what is RabbitMQ and Kafka and distributed messaging queue, but that is completely fine. If you go and read about them after this class and then refer to the notes, you will be able to understand it. Okay? So don't ask questions if it is not clear. I think if this is not very much clear, right? Okay. We will just cover I will just talk about what is producer, what is consumer, what is a broker, what is a topic within a Kafka, which you might not know. That is completely fine. You will know after the class, and then that will make sense. So now let me just complete the design, right? So again, this was the client. The client was sending the request to the YT server. The YT server was persisting the video on the database and getting the URL out of it. After the URL, it was sending the link. Now it is not sending the link to the server, but it is directly for processing. It is sending the link to the messaging queue or Kafka. This is for processing, right? It has sent the video, and as soon as it sends the video, it is free. Like it just sends the request to the messaging queue, which is basically a queue So there will be stage one. Again, you might not be able to understand if you don't know. There are topics within Kafka. So there will be stage one topics. And with each topic, there will be a queue associated with it. Right? And with each topic, there will be a queue, a producer, and a consumer associated with it. Right? All of it will be handled by the broker. So the stage one topic can be Indian law. Again, other aspects can be copyright, YouTube policy, and the YT server will become the producer for the stage one topics, and it will start going to here. Right? Make sense? So it will give it to this, but then this queue will have multiple threads. Within this queue, there will be slow queues, fast queue, multiple queues, and then they will send this request to a server, which will complete the request, like these set of servers, which are going to complete this request. And once they complete it, they become the consumer for stage one topic and producer for stage two topics. Then stage two topics will start, and they will again have multiple queues. They will transfer here, and then these will happen multiple stage two topics. Then again, they will be given to a system that will do those requests. And once these are done, then they will be passed on to some stage three topic. Once these are done, then they will be passed to some stage four topic. And once everything is done, then the Kafka will go and update the response in one database. Can be like a SQL database, which contains the video status right now. And once it is updated, it can send the notification to the client, or the client, when again receives back again reloads the page, then it will get it from here and it will say that it is processed. Does this make sense? This whole of is a messaging queue Kafka, which you have to read after this time. Within the Kafka, read about multiple things. Read about what is a broker, what is a consumer, what is a producer, what is a topic within a Kafka. After this, what are small queues, like fast and slow queue, and why is it called distributed. If you read about all of it, it will make sense to you. That yes, all stage one topics should pass. Yes. So all stage one topics should pass and go to one server, and then from there they will go to the next set of servers. Yes, there will be one server that they will pass and then move to the second server. Okay. Does this look like a pipeline? We will have if any process fails, then there are fast queue and slow queue within the messaging queues, which retries back again. If any operation succeed with like negative outcome, then there will be all the requests will be sent to one server, which will become the producer for the next. Yes, Rahul is delegating to Kafka. So this was Rahul, which was getting a lot of videos, and now it has delegated this to his wife, which is Kafka, and now videos are like kicks, which are now handling it. Okay, does this make sense? So does this look like a pipeline? Tell me, does this look like a pipeline? You define business logic. It's very easy to implement Kafka. You can learn implementation as well. Very easy. Looks hard, but very easy. You can. Okay. Does this look like a pipeline to you guys? Like, does this look like that there is a pipeline which is going to happen? Right. So this is what is known as an ingestion pipeline. Ingestion, since we are ingesting the video in the system, right? Ingesting video in system, and pipeline because it's following a pipeline of steps, and video because we are ingesting video. So this is how the first part of the puzzle looks like, where there are content creators and they are uploading the video from the ingestion, which is using the ingestion pipeline to finally make the video available for distribution. So that was the first puzzle. The second major puzzle is now distribute this. Now there is a distribution system which has to distribute these videos to a large set of persons. So the next we will cover is now distribution of video. What are the major challenges in distribution? If you see, first is low latency. Do you want to wait for your video to be loaded, or do you want it to be loaded very, very fast? You want to be loaded very, very fast, right? So you want low latency, right? But you are handling it at a very big scale. What happens when scale of a user is very, very big? The major problem you will see after the break is that you have to handle very high bandwidth. And that bandwidth you have to solve at nearly very, very low latency, right? So this is something that we will solve after a very quick break. Before we move forward, I also want to take 5 minutes of your time to talk about this one query which I get a lot is how do we, some of us are working in service companies, some of us are working in initial stage startups or good startups, some of us are college students, and we have this goal of making a transition into top product companies like Zomato, like Arsation, like Google, like Paytm. And you want to know how can we make this transition possible for ourselves. So let me cover this quickly and how Bosscoder can be a platform which, if you want to check out, can help you in this. So to give you my career of last like 3-4 years, I have cracked interviews at Microsoft, at Amazon, at Adobe. At the same time, I have failed interviews at Goldman Sachs, at Google, at SmartBreaks, at Fidelity. So I have seen bunch of failures, bunch of success in the past of my career as a tech person within the domain. And according to me, this is what you need to get into these top product-based companies, which has helped me a lot in my career. So you have to build some skill sets. One of the most important skill sets which are any good product company or any top product companies will ask you is problem solving in DSNW, which is, are you able to solve coding problems? Are you a good problem thinker? Given an ambiguous problem, which looks like a real technical problem, can you be able to solve it efficiently and correctly, and are able to come up with multiple approaches around it? Problem solving problems on LeetCode, on Code Forces, CodeChef is a great way to enhance that skill set, and that's very, very required to get into top product companies. The second skill set, which is asked a lot by top product-based companies, is something known as software designing. I rather say software designing rather than system design, because software designing itself consists of first low-level design, where you are writing good quality of code. You are writing a code that can stay for 15-20 years, that is easy to understand, that is easy to read, that is easy to debug, that is easy to test, that is easy to extend on top of it, right? Very, very important to do so. If you are writing code for a service that is going to stay for the next 15-20 years, very, very important that the code health is good. Low-level design, design patterns, solid principles, all of that combinedly comes under low-level design and is very, very important for a good software engineer to have. The second aspect is scalability, right? Once you know how to write code for a system, how do you scale it is another aspect, right? How do you handle the scale at which YouTube works, or scale at which Netflix works, or scale at which Zoom works, or scale at which our messaging platforms like Telegram, WhatsApp, Slack works. That is very, very important to know second. And the third aspect is how do you go into design database? Again, how do you go about designing a database through which you are distributing the data more evenly? Like, how do you normalize the database? Then once you have normalized what is the primary key, what is the secondary key, how are different tables going to talk to each other? Then once you have normalized, how do you going to denormalize in order to make your queries faster, right? That is also very, very important. So overall aspect, system designing or software designing is all about that and very, very important and asked in all the top product companies, even asked a lot from people who are senior in the position. Then I also believe CS fundamentals is very, very important. Not asked too much in companies, but it's very, very important when you are working in a company. For example, operating system, how does threading work, concurrency work, how does CPUs work, how does cores work, how does thread and cores relate to each other, what is deadlock, what is, context switching, and all those aspects are very, very important to know. Computer network, very, very important to know. How is the internet working as a whole? How are information getting passed on? We are designing YouTube. How is a user connected to the YouTube server? Is it HTTP call? Is it a WebSocket? Is it long polling? What it is, very, very important to know. DBMS, again, very important. We already covered it above. Object-oriented programming becomes the backbone of low-level design, very, very important. And once you have all these skill sets of problem-solving, system design, CS fundamentals, having very solid understanding of hands-on experience of them, that you go and take up any project like designing Netflix, design the front end of it, design the back end, design the database layer, then deploy it over cloud, and then able to scale it to multiple millions of users. is a skill set that is very, very important to have. So that is also something that is that makes you a solid software engineer. I think all these skill set is what makes you a very good engineer and gets you into some of the top product companies. So these are the skill set you should focus on. Now, how do you go about learning them? Problem solving, very, very important to structure your preparation. I see a lot of people fail while doing problem solving. So it is very important you structure your preparation. Why? Because, like, to give you an example, like, let's say you want to become good at DP, dynamic programming. You have to be good at iterative approach first. Then you have to be good at recursion then you have to practice recursion on trees. And you should have a solid understanding of creating recursive function. And then you can do very good at dynamic programming. Very, very important to structure your preparation. Consistency. No one have learned problem solving in 1-2 months. Everyone, it takes 6 to 7 months, 4 to 5 months to learn problem solving. Remaining consistent is important, and then solve more and more problems. System design, there is a lot of resource for problem solving, DSA on YouTube. System design, comprehensive and structured resource is not there. So follow a comprehensive and structured resource. You can buy any, like, I have not seen any good free content on it. So you can buy any paid course to become very good in a comprehensive manner, and then do some mock interviews with a senior designer or a senior engineer who helps you overcome some of the mistakes you do in design. CS fundamentals, do it a concise preparation related to the topic. And project development, I think learn the framework, any framework, merge stack, mean stack, understand the project architecturally, write the code, and then deploy it over cloud. That are some of the aspects that you should focus on. In overall of this journey, one person that has helped me over this journey is Manish, like my big brother. He is an IIT Dhanbad graduate from CSC, already have worked at companies like Samsung, Curie, Arsatium, multiple companies. So he has helped me throughout my journey a lot by helping me know all the right things, like do this, do this, do this, do this, do this, and unblocking me when I am blocked. That is why I really think that mentor helps you a lot. A mentor gives you the guidance and the direction like a big brother does, and it really stops you from following this orange path, right? It's very, very obvious, right? Like if you are learning by yourself, you will follow the orange path. You will do some mistakes for sure, and you will learn from that mistakes, and then you will improve upon, and finally you will reach your dream goal if you are consistent. If you are not consistent along this difficult path, then that might not be possible. But if you're consistently trying by yourself, you will definitely reach your dream company, but it is going to take a lot more time, since again, you are going to do mistakes for sure. What a mentor who has already done that path does for you is it stops you from moving that path, that wrong mistakes, and takes you on a green path, which takes you to your top product companies very quickly, which saves you a lot of months of time, which essentially is a very, very good thing for you as a working professional. Every month is very, very important for you. Every month you waste towards making a transition, you are losing on a significant amount of money itself. So that's also a very good thing that a mentor provides you. With both of these concepts of skill set required and mentorship, I also want to introduce you to Bosscoder Academy's 17th cohort. Bosscoder Academy is a 2-year-old company. We have a Bosscoder Academy is again a 2-year-old upskilling program, which is very structured, very personalized, very mentorship driven, and it helps you become a very solid software engineer and then gets you placed into top product-based companies. We are a program which heavily focuses on problem solving, system design, CS fundamentals, and full stack development. This is how the curriculum looks like. Within the first 4 months, we focus on problem solving in DS and Algo. Our curriculum is very, 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 very structured. Delivered live by people working in top product-based companies and who are also very good teachers. We give you daily assignments and homework problems, which makes you practice problem every day. We make sure you are consistent by first creating your schedule, helping you work with your peer community, and also assigning your student success manager, which again keeps check on whether you are progressing or not. Then the next 3 weeks we focus on in CS fundamentals, covering those 4 topics: operating system, computer network, DBMS, object-oriented programming, in a very structured and concise way, so that you learn all the fundamentals which are needed for you to be a good software engineer very, very quickly, and then you solve multiple problems. Then the next 2 months we focus on system design, where you learn low-level design, high-level design, DB design schema. Again, a very comprehensive and structured resource. All classes within Bosscoder are live classes. They are taken again by people who have industry experience and have worked at top product companies. You are assigned a mentor through which you have design discussions, so you make sense of how to go over design discussions. That is something you learn as well. And then finally, in the last 1.5 months, we combine all our knowledge to build full stack development projects, in which you learn a framework. For us, we choose Merge Stack, and then based on Merge Stack, you work on 2 industry relevant projects where you do everything end to end, taking a project, defining the statement, building the front end, back end, database layer, deploying it over cloud, and scaling it to a lot of users. That is something you work on as part of full stack development projects. After you are done upskilling in the next 6 months, become a very confident person. there is 1 year of placement support, which basically helps you build a strong profile, a strong resume, strong LinkedIn profile, so that your resume gets shortlisted faster. We help you find multiple opportunities with you through our partnerships. We have multiple good product-based companies through our referral program, where we have a community of 3,000 plus people already, and we provide referrals through them, and we share you hiring requirements, and then again help you while you are going through the interviews with on-demand mock interviews. So in essence, Bosscoder is an end-to-end program which first help you upskill to become a great software engineer, and then finally provides you career support to make that transition possible. I am asked this question a lot. That is why I just mentioning Bosscoder is not a data structure and algorithm program. Bosscoder is an end-to-end program that helps you upskill to become a great top 1% software engineer, and then finally help you get placed into top product companies. These are the results we have delivered for working professional in the past 1.5 years. We have 762 learners placed at 120.34% of salary hike with ROI of 6.25x. Pre-Bosscoder, their salaries used to be 11.1 LPA on an average. Post-Bosscoder, they have seen a average salary of 24.40 lakhs per annum. This is how our one batch looks like, and based on the years of experience, this is what as an average salary we have seen. These are the results we have delivered for college students. There are different batches for college and working professional. So we have 465 learners placed at a highest package of 82 lakhs per annum and a placement rate of 94.1%. Again, post Bosscoder, they have seen average salary of 20.15. This is what our placement ratio looks like on tier 1, tier 2, tier 3 kind of colleges with what is their average salaries they have seen. Some of the reviews, I will not go through them right now, but yeah, we have seen people shift from service companies, banking sector, students from good colleges like IITs and ITs, transitioning into top product companies, from tier 3 colleges, after graduation, not getting job into good product companies. So yeah, if you are interested to know more about how we can help you or how Bosscoder can be a curriculum that can help you, you can fill out this Google form, and someone from our team will reach out to you to help you connect, right, and help answer any question that you have. Yes, so for working professional, yes, the classes happen 9 to 11 p.m. majorly on weekends. So yeah, it is designed for working professional. For college student, it is designed for college students, so you will not find any problems like that. Even there are recordings like, so for example, even if you miss some classes, there are whole recordings that are available within the course. This is for DSML, but if you like, even if you miss some classes, there are recordings available which you can watch, like that are immediately available after the class. All these are live classes. You get notes, you get assignment problems, which again you can solve. These are again on the Bosscoder platform. So whenever you solve a problem, that immediately reflects into your profile, and you get these coins. Based on these coins, you can buy some things from our Bosscoder store, which again is kind of incentivizing good behavior. You work with learners in a community, so you have like rating, like you see, like for example, Rahul Dev. This is again for DSML, but the similar is for HD. You like very competitive in terms of you compete with other people, very healthy competition. There's a very active community. Like these community are again people who have joined Bosscoder. So as I say, 3,000 people have joined. Out of those many are in our community. Very active community. It's not like stagnant community. Very active community. Placements that are happening, we keep sharing placements that are happening throughout Bosscoder. Even if Holi is getting played, we share Holi celebrations throughout. Project discussions are happening. Everything is happening. Like very like active community. So yeah, if anyone of you is interested, then you can fill out the Google form, and someone from our team will reach out to you for any questions that you might have. Great. So let's start with distribution. So what is distribution? Distribution is that you will now have this video. Now distribute it to a lot of very big audience, right? Make sense? This is distribution, right? Everyone clear with it? Let's start with the very first approach of, let's say we want to just distribute video to one person. Let's first solve this, and then we will scale, right? Let's say only one person is there on our platform who watches video. Let's make it very efficient for it, right? So let me use the approach one for the first video. The first approach that we can have for one person is that we have this, let's say, complete video 1 hour, and this is the server, YouTube server, where the video is present, right? And this is the client. This is, let's say, the client laptop. So what does the client does is clients The first step is it asks for the video. Then it downloads the complete video. Download the complete video, and then once the video is completely downloaded on the client, then it streams the video. This is the approach one, right? Tell me the advantages and disadvantages of this approach. Yeah, disadvantage is that downloading of big files will take a lot of time. So user has to wait a lot. What is the advantage? The advantage is that there will be no buffering. Post video start. Does this make sense? Right? So now let's combine both of these good and the bad while to create a good solution, right? So we definitely want to keep the advantage, but reduce the disadvantage, right? Why is the disadvantage there? Because you are downloading large videos. If the video size is small, tell me, will this be a problem? Let's say the video size is 10 seconds. Will this be a problem? No, right? No. So in approach 2, let's do one thing. We have this 1 hour video, right? Or 60 minutes video. Let me divide it. The first step let me do is divide this video in small chunks of 5 to 10 seconds, right? So I will divide this video in small chunks of 5 seconds each. Does this make sense? This process is known as chunkification. Okay, so you divide this whole video into small chunks. So now what do you have is a small video of chunks. Which algorithm we use? Just divide them into chunks. Like you're not, right? So you have this whole chunk, small chunks, and then what the client is doing is client is downloading these chunks one by one. Downloading chunk and playing it, right? So download chunk, download one chunk, play it, download second chunk, play it. Now tell me, does this make sense? Is till here make sense? Then we will make one modification to this. Is this making sense? A quick yes. Right? Okay, great. If this makes sense, so tell me, can you improve it? How can you improve this even better? Yes, download second chunk while playing it. Okay, that is already we are doing, right? That is what I have written here. What more can you do? That is definitely we are downloading second chunk after downloading first chunk. Can we do something else as well? Yes, Manish is right. Let's download multiple chunks at a time. Right? When you play YouTube video, have you seen that these are the 3 things that are there? Like the first thing is that there is this red bar until which you have watched the video. Then there is this gray bar from where the video is downloaded up to. And then there is the white bar. So this video is already downloaded. These chunks are already downloaded for you way in advance, right? Which makes sure that you are not buffering too much, right? So now what can you do is on the client side, instead of downloading one chunk, you can download multiple chunks. So you can download, let's say, 4 chunks at a time. Again, not too much, because too much parallelization leads to multiple threads being open, which leads to slow output, right? So you download multiple chunks at a time and then play chunks one by one. Okay, is this making sense? Yes, Pranshu is right. What is the one problem that this approach will give you? One problem that Pranshu is also mentioning that this will give you is order of chunks is important. You tell me, can you play chunk 1, chunk 3, chunk 2? Can you do this? Is this allowed? No, right? Or can you do this, that chunk 3, chunk 1, chunk 3, chunk 4, and you just left chunk 2? Is this allowed in recorded sense? No, right? In recorded, this is not allowed. In live, is this allowed? In live, this is allowed. But in recorded, this is not allowed. So this can happen. How this can happen? Let's say the chunk 1 gets downloaded. It's success. But when you were downloading chunk 2, something got bad and chunk 2 does not get downloaded. Right? Then you do not have chunk 2, but chunk 3 gets downloaded, chunk 4 gets downloaded. So will you play chunk 3? Yeah, that will, if the user clicks front, then you will start loading chunks from there. That is a different thing. Right? So this is the problem. How do you handle this? How do you handle the order of the chunks? You handle it using something called as a manifest file. I think if you even go to YouTube and even go to inspect, then you will find, if you go into network, you will find the manifest file getting loaded. What is a manifest file? What happens is, if this is the YouTube server, then the YouTube server will have the manifest file of all the videos and the video file itself, So what happens is, the clients downloads the manifest file. What is the manifest file? Manifest file is nothing. It's just a file which contains the order of the. Just give me 1 minute. Hello. मैं क्लास में हूँ, मास्टर क्लास में है ना. So what does a manifest file contains? Manifest file just contains the orders of the chunk. For example, chunk 1, chunk 2, chunk 3, chunk 4, chunk 10, right? Just orders in which the chunk has to be delivered. And then on front end, you can have some tick marks. That if chunk 1 is loaded, then you can play the chunk 2, right? So to play chunk 2, chunk 1 has to be loaded and play. Right? Since it knows the order of the chunks, it will make sure that the video is getting played in order. If this fails and this gets succeeded, then re-download it and then play chunk 2 and then play chunk 3, chunk 4. Does this make sense? So does the chunkification make sense? Chunkification with manifest file. So chunkification with manifest file clubbed with quality control. Quality control means that you have the same video in multiple dimensions. Right? We'll make sure that you are able to stream video fast for one single user. Okay. Now let's think of problem that when you take this approach to multiple users at scale, what happen, right? When you take the same approach to multiple users, the one problem that will happen is that the location from where you are streaming. So let's say, let me just forget my drawing, but let's say you tell me how many data centers are there for AWS in India, right? Tell me how many data centers are there for AWS in India or for Azure in India. AWS here, there are 2 data centers. I think one is in Mumbai and one is in Hyderabad, right? Or in Chennai, I think. Chennai, yes. So one is in Mumbai and one is in Chennai, both in the southern region. Azure, there is one data center in Hyderabad, right? So let's say someone sitting in Delhi, right, have to now go to Mumbai data center to stream the video, right? If this location is large, like if big, then what will happen? The data transfer, the data packet transfer will take time and will lead to higher latency. Okay, that is the one problem that you will face while scaling this up that people are going from places like Mumbai, Chennai, like Mumbai or Jammu and Kashmir to directly in the southern region of India, which is a very large distance, and getting data from those their places, which is going to take a lot of time and going to increase latency, right? Make sense? The first problem makes sense? A quick yes. Okay. The second problem that you will face is the bandwidth problem. What is the bandwidth problem? Let me share you what is the actual bandwidth problem that you will see. For that, let's do some analysis. So you tell me how many users, like consumers, will be there on YouTube. On an average, how many users will be there? $100 crore, yeah. Okay. Let's say a billion people. Let's say 1 billion people uses YouTube, right? Then tell me how many will be daily active users, right? Let's say again 20% of them watches daily. So let's say 200 million people are watching video every day. Okay, makes sense. Now tell me how many videos they will be watching on an average. Let's say around 10 videos, right? Some people might be watching a lot of videos, some people might be watching less videos. Let's take on an average that they are watching 10 videos in a day. Okay, if they are watching 10 videos in the day, then number of videos that are getting streamed is around 2 billion videos in a day. What do you think would be the average size of one video? Let's say 10 minutes, right? I'm just doing this calculation quickly by myself only, right? So you tell me, what do you think, how much duration will be the watch time? Again, like people don't watch complete video on YouTube, right? People have a lot of distractions in life. So whenever they are watching a video, there are a lot of thumbnails in the right side, which they can click and then go into another video, right? Also, like if you see, even you see this class as well, we started with 150 people, odd people, but now we are 60 people, right? So there's a lot of distraction that goes on and people leave in between. So what do you think, how much have been streamed? Stream matlab how many packets would have been downloaded, right? So streamed video length, let's say 50% is getting streamed. So let's say 5 minutes is getting streamed. Okay. So what is the watch time, or I would say download time per day? It will be 2 billion videos that are watched in a day, and each video is watched for 5 minutes. So that will be 10 billion minutes of download time, right? Let's say 1 hour of video takes 10 GB of space, right? Okay, or will that be right assumption? Given that it will be HD or SD, right? Or we can just say, if we take on an average, I think we can take 2 GB of space, right? So that means 1 minute will be 2 GB by 60 of space. So what will be 10 billion minutes? It will be 2 GB by 60 into 10 billion, right? This much of space, this much of download is happening from the YouTube server. So can you do it? I'm just writing it 10 as 9, right? Just easing out my calculation. So it will be 300 million GB. What is a million? Million is a 10 raised to the power 6. What is a 10 raised to the power 6? 10 raised to the power 3 into 10 raised to the power 3. What is a 1000 GB? 1000 GB is a terabyte. What is a 1000 terabyte? Petabyte. So 300 petabyte of data transfer in a day, right? Does this make sense? So if this is the YouTube server, okay, if this is the YouTube server and these are all the people that are streaming from YouTube, then in one day, they are downloading around 300 petabyte of data. Okay, Make sense? So let's calculate the bandwidth. Bandwidth is data transfer within a second, right? So how much data transfer is happening in a day? 300 petabyte. And let's divide it per second. So per second will be 24 hours into 60 minutes into 60 seconds. So can now someone do this calculation for me? 1000 terabyte by 24 into 60 into 60. Let me cut this by, let me make this 1000 only. I will cut this with this. I will cut this with this. I will make 24 as 25, right? And will cut this with 4. I will make this 2. I will make this 20. I will make this 3. I will make this 10. And then I will make it 3. 3 terabyte of bandwidth, right? 3 terabyte per second. Yeah, like exact can be 3.47. I have just rough did the calculation. This is the bandwidth. You tell me, is this a small bandwidth? How much is the bandwidth at your home? Like if I see my internet speed test, if I do at my home, which is I run one of the fastest internet right of Airtel here within Delhi NCR. So even for me it is 100 Mbps, like around 100 Mbps, small Mbps. So this is the bandwidth that you need to support every per second. Handling this bandwidth is the second problem. Is this making sense? There were two problems with the scalability of this video to millions of users. The first problem is that we are downloading from a faraway place. The second problem is that the bandwidth is too high. If you solve these two problems, you will create a good distribution platform. How will you solve these two problems? Is the two problem making sense? A quick yes. Okay, great. So tell me, how will you solve these two problems? You have two problems for distribution. Two problems for distribution at scale. One problem is very simple. Distance between client and server location. And second is bandwidth of 3 terabyte per second, which one system cannot handle by themselves. Yes. Yes, the right answer to all of these problems is a CDN, which is a content delivery network. Like there are multiple providers of CDN, like Akamai, like CloudFront is, I think, from AWS itself. AWS has their own CDNs, which are known as CloudFront. What is a CDN? Do you guys know what is a CDN? Or you want me to like give you a small analogy? Again, I will not explain it completely, but will give you a small analogy. Okay. If I give you a small analogy, CDNs are a bunch of small servers, essentially known as edge servers, which are distributed all across the globe. Right? So for example, there might be one server in India, two servers of AWS, but edge servers will be multiple. There will be multiple edge servers all around the world, all around India, all around the world, which can take up some traffic. So to give you an example, if I search Akamai number of edge servers, then Akamai have right now around 340000. If I say right now, then they have this much edge servers all around the world in 130 plus countries. Okay, what happens with edge servers? The first problem is resolved, right? Because now the first problem is resolved, that now you are streaming video from edge servers rather than the database itself, the data center itself. This reduces the distance between the client and the place where the video is located and is streamed from. Does this make sense? A quick yes. Yes, no, this is making sense. Okay, great. So that is the first answer. Second is now bandwidths get distributed. Yes. How CDNs work, I will just cover in 1 minute. Let me just cover how they solve the problem. Just consider there are videos on the CDN, which CDNs are network of small servers known as edge servers that are distributed all around the world. Somehow your videos have reached the edge server, which is close by to the client, right? So your first problem is resolved. How does it reach it? I will cover in 2 minutes, but just think of it that it has reached somehow. So with that, the first problem is resolved, that you can stream videos from a nearby place. That is the first problem that get resolved. The second problem also get resolved because now the bandwidths get distributed. Now, previously, when all the people were streaming from the Netflix server, now they are streaming from edge servers. So now your 3 terabyte per second of bandwidth is distributed among edge servers. So again, let's take the Akamai example. You have 340,000 servers. Let's say out of these, I take 1 lakh servers, edge servers. So what will be my, and considering that the traffic is distributed equally, that is of course not the case, but consider that the traffic is coming equally from all around the world. What is the edge servers are small servers distributed all around the world, right? So what is CDN? CDN is network of small servers all around the world, right? Those one small server is known as an edge server. Okay. And there, for example, Akamai have 3,40,000 of those edge servers at 120 plus countries. Small servers close to user. Yes, you are right. Again, read more about it after the class, but yes, right now you can take that as an analogy. Let's say we have 1 lakh server. So now tell me what is the bandwidth per edge server? 3 terabyte per second by 1 lakh servers. So what is 3 terabyte? 10 to 3, 10 to 3 GB, MB. Right? I think this will be it, right? Terabyte is GB into this, yes. Like this. So you become 30 KB per second. Even like, so you even don't need this much. Let's say even if you have 10,000 edge servers, just 10,000, that will get the thing done. You have 10,000, then you will cut this. This will be your 10. So it will become your per second, which is acceptable, right? I think I did some calculation. Does this make sense? So what edge server does is it basically distributes the traffic. So even with 1,000 of edge servers, you can now have less bandwidth per each edge server. Does this make sense? So how does edge server solves the problem of bandwidth? Yes, yeah, I might have done some calculation wrong, but yeah, you can do that calculation. But essentially what I mean is that the bandwidth get distributed among edge servers. That makes sure that each server is not handling very, very high bandwidth, which is not possible. Okay. Now let's just quickly see how does the whole design, let me just first cover how does CDNs work in very, very quick sense, and then we will see the complete design, and then we will cover so 10 minutes or more, and we will cover wind up the class. So CDNs work in a hierarchical format. This is usually a 2-class topic. I think we just cover it in one each time. But yeah, let's say CDNs work in a hierarchical format. What does it mean is that, let's say a user is in Delhi. So the user will go to the Delhi CDN, right? Watching a video. If the video is in the Delhi CDN, it will be streamed from here. Otherwise, it will go to the, let's say, North India CDN. If the video is in North India CDN, then it will be cached in the Delhi CDN and then shown to the user. Otherwise, it will go to the, let's say, India CDN. Similarly, same thing will happen. If it is not even present here, it might go to the Asia CDN until it reaches the data center, which is the origin. Origin is the AWS data center. which is the source of truth. Where is the video present actually, right? And it keep caching down the each layer, right? So the first user who is coming, let's say the Rajat is the first user that is watching the video. It will take a lot of time for him, right? It has to go through all of it and then cache it at multiple places. But then the next user that is going to watch the video from Delhi is going to directly get it from the CDN. Or the next user which is going to watch it from J&K might not have in the J&K CDN, but will get it from North India CDN. CDN cached it, and then everyone from J&K will get it quickly. Does this make sense? This is how CDN is like caching, and it makes it quicker. Just remember the eviction policy. Make sure that have a eviction policy in place so that the videos get deleted from the CDN after some time. It can be on multiple aspects. It can be on least recently used. It can be least recently watched. It can be based on time, whatever you want to keep it, but it has to be there. Does this make sense? Right. So if I draw the whole distribution pattern, then there will be client. The client, the first request always go to DNS, which is like a domain network service, which gives the to which you gives the domain and it gives you the IP address of the load balancer. To which then it goes to the load balancer. This has been same in the ingestion pipeline as well. I have skipped it, but there are all these load balancer and everything here as well. Then there are multiple app server layer here. It will get one of the link for the video that, okay, play this video. It will give the manifest file and all of it and return to the client. And it will also go to the, it will also get the, it will give the manifest file. It will give the video URL and everything to the user. The user will then get the video URL and then will again go to the DNS and then will ask for the CDN URL, like CDN IP address, that which CDN to hit. Now there will be a global CDN here from where the client will form connection and will start streaming the video. If the CDN has the video, then it is fine. Otherwise, it will internally work in a hierarchical format and get the video from the origin, which is the database layer. Right? Once it gets the video, it will cache it in and then will start streaming the video. Okay. Overall distribution channel makes sense. Right? So if I draw the recorded sense, I am just coming it in. If I just conclude the recorded part, video streaming, then it's kind of, you might be getting a sense of it that there are some content creators. Now I think this will be making more sense to you, which are creating some videos, multiple videos, which are passing through ingestion pipeline. Which system we have already drawn. This makes sure that the video is available on the servers and ready for distribution, which then goes through a distribution pipeline or a distribution system, which responsibility is to populate these videos to consumers at scale, at low bandwidth. Right? Does this make sense? The overall recorded video streaming, and then let's go to live streaming. Quick yes, if this makes sense. Then let's cover live streaming in 5-10 minutes. Okay. So live streaming, let's come to live streaming. Let's start from the very beginning. Let's say you are going through a cricket match. Let's say Asia Cup is getting hosted on Jio Hotstar. Right? I'm saying Jio Hotstar. Disney Plus Hotstar, right? So let's say this is the cricket stadium, right? This is the cricket pitch. 3 wickets, cricket, bowler. Then do you understand that there will be multiple cameras? Some facing the ground, some facing the crowd. There will be multiple cameras that will be on the cricket ground. Yes or no? Yes. Okay. Yeah. And then all of these cameras, for example, camera 1 will be sharing one stream of video. Camera 2 will be sharing another stream of video. Camera 3 will be sharing another stream of video. Camera 4 will be streaming another stream. Camera 5 will be streaming another stream, like this. Multiple cameras will be sharing multiple streams of videos. Out of those streams of video, there will be a director, right? Which is again a person who will be heavily driven by tech and this person will choose one stream to display to the user, right? You cannot show all the streams. You are going to show one stream at one point of time, right? Make sense? So this one stream of video is then made by the director and then broadcasted on TV and passed to platforms like these OTT platforms, if I say, like Geo or like all of those. All of this, cameras, having director, all of this here, this all is the work of the TV broadcaster and not the work of Geo Cinema or Hotstar or anyone, right? All of this is the work of the TV broadcaster. The TV broadcaster gives them one stream of video to the OTT platform, and then the OTT platform responsibility is to show it at scale, right? Yes, it's not real time. That is why, like right now, they still have gotten the stream. Now they have to distribute it, right? So now we will come, where will the lag will come? We will start talking about it now, right? Now, do you understand that the OTT have now gotten this stream of video stream, and they're consistently getting it back to back here? Does this make sense? A quick yes. Okay. Now this stream has to pass through the video ingestion pipeline. Now again, the video ingestion pipeline will again consist of upload and processing. But the video ingestion pipeline will not take much time. Will take some time, but will not take much time, right? Stream of videos, right? They will send the stream of video. Now again, that is happening real time. So that stream is very small. This stream is very small because it is happening in real time, right? Make sense? Now the processing will take care of a bunch of steps, but again, a lot of steps will not be needed. For example, maybe policy checks will not be needed. Copyright maybe will not be needed, right? Or Indian law will not be needed, right? Have you even seen that YouTube lives sometimes have kind of videos which should not be shown, right? For example, people doing like bad things are streamed on YouTube, right? And YouTube cannot stop it because they are not right at the time of video streaming, live video streaming. They are not going through all of these checks. But when that video finally becomes available, after some time, it gets deleted, right? Or it does not get available after streaming, right? Why? Because again, that violates the law of YouTube, right? So now all of these processing have multiple like very less stages here. Also, the processing, the ingestion will not take time because of the first reason, the number of steps are less. And the second reason is the stream that you are working on is small. Stream of video is small. You tell me, chunkification will take more time on a 1 hour video or on a 2-minute video? On a 1 hour video, right? So all the other steps like chunkification, quality control, all of that is going to take less time, but is definitely going to take some time. That will include lag from the TV broadcaster, right? Does this make sense? Everyone clear with it, right? Now, after ingestion, they have to go send the video. The video is then persisted and then has to go through the distribution pipeline. In distribution pipeline, what will work better is the one approach that works in recorded. In distribution, that is the difference. In recorded, the better approach is that the user will ask for the video from the CDN, and then the CDN will go to the origin and then will persist video. Like it will go like this, right? However, in live, the better approach is that the user is here, CDN is here, and your origin is here. Origin means database. So here, the video from ingestion pipeline, the video goes to the origin and the origin push itself to the CDN rather than user asking for it. And then the user is asking directly from the CDN, right? So to the CDN, it's a push mechanism. Here, from CDN to origin, it's a pull mechanism. CDN is pulling videos from the origin, whereas here from CDN to origin, it's a push mechanism. That origin is pushing the video itself to the CDN in real time, right? But that is same. It will again use CDNs for distribution and then will distribute it to millions of users who are watching the live stream. That is how streaming works. Live streaming works for OTT platforms in a very, very broad sense. I think this is all I wanted to cover today. I think this is the end of the lecture. If I conclude quickly for all of you, we started the session with the agenda. Then we understood the ingestion pipeline in the first half. Ingestion pipeline as well, we took multiple approach. We took approach 1, very simple approach. We optimized based on that with approach 2 on parallelization. Based on this, then we moved to approach 3 with your Kafka, and then we completed ingestion pipeline. Then we moved into distribution. In distribution, we first learned for single user. For single user, we come up with approach 1. Then we defined approach 2 with chunkification. And then we defined approach 3, which is chunkification plus manifest file. Then after this, we started understanding distribution for scale. In this, we understood problems. In problems, we understood that the first problem is difference in location. And the second problem is bandwidth. And then we understood how all of this can be solved using CDNs, and then how CDNs work. Then together we finalize the recorded streaming. And finally, then we create this as a fundamental understanding of how the streaming platform works to extend it to live streaming platforms. In this, we quickly understood the responsibility of TV broadcaster. And then we understood ingestion, like how ingestion will be small in terms of this. And then we understood distribution with one change of push mechanism rather than pull. Okay, I think this is all we covered today.
I hope you found the class to be useful. If you did, don't forget to like the video and subscribe to our YouTube channel. This helps us create more such valuable content for you. And in case you have any doubt, please let us know in the comment section and we will answer your queries. Also, don't forget to check out the Bosscoders program, which will help you become a top 1% software engineer.